what you would have done last year was a bit about multiplication of two fractions. Okay, so if we go back in the day, back to junior cert fractions. Okay, I've always said that's 18 over 27, and I said that's multiplied by 3 over 2. Okay, you could do it this way: 3 by 18 is 54. And then 27 by 2 is also 54. 54 divided by 54 is 1. Top by top multiplied by bottom by bottom, correct? Now, what we're going to do is something different, guys, okay? What we're going to do is we're going to make sure everything's fully factorized. So when we look at the 18, we can turn 18 into 6 multiplied by 3. We can turn the 27 into 3 by 9 maybe? Or 9 by 3. Now look at this. What can I cancel here?
3.
I can cancel that 3 with that 3. Or I could have cancelled that any 3 on the bottom with any 3 on the, because everything is being multiplied. Technically that line reads this. But I can join them beside you right away. Technically this line reads this. And the bottom line currently reads that. You agree with that?
Yeah.
Everything being multiplied on top, everything being multiplied on the bottom. Now, I go one step further. I start breaking down the 6 and the 9. How do I break that down? Breaking down the 3 multiplied by 2 is one of them, isn't it? And the other one is? Huh?
3 multiplied by 3.
Yeah, exactly. So there's 3 by 3 by 3 is still 27. And 2 by 3 by 3 is still 18. Yeah? Now all of a sudden I'm in a position where I can start going you with you, you with you, you with you, you with you. To say the word cancelling, it's not technically cancelling. It's dividing one number by the other number to become the number 1. So the answer is 1. Now, what we do next is we have either a multiplication or a division question. I'm going to take question 26 because question 26 covers everything. Question 26 starts off like this. It's currently divided by xy plus 5y over x squared minus 3x. I only taught you how to multiply so far, correct? So, what is division? 3 over 2 divided by 5 over 7. How would you do that at junior cert? Turn the other side upside down and multiply out normally. This is no exception. I turn the division 1 upside down and then I start trying to break it down because it's multiplication. So I'm going to turn it upside down. So I'm going to say it's multiply. Now I'm going to put the multiply in a green, just so I'm not getting the x mixed up with the x squared. And then we're going to have x squared minus 3x xy plus 5y. Now what did I tell you guys last year? Everything needs to be fully factorized. Is everything fully factorized at the moment?
No.
So you look at that, and what does that break up into? X plus 3, x plus 5. Okay, I can't keep going through reference numbers all the time. You got to know them at this stage. Okay, the bottom one? Or the other way around, yeah. This one here? Huh?
X bracket x minus 3.
Yeah. And after that?
Y bracket x plus 5.
Okay. Looking left and right, what can I make disappear?
X minus 3 and x plus 2.
Yeah. After that?
X plus 6.
And after that? And what's left over? Alright. How'd you rate the difficulty?
What page is it? Easy ones here.
It's on question 6, page 26. Yes?
So if it's division, you can just really
Flip the second one upside down and work as if it's multiplication.
Okay.
So basically question 24 is question 24 and 26 are very similar as is 25. Just gotta break them down and chop them up. Now, this one's a bit more difficult. 27 would be okay. So I've done 26 and 27. What you're looking at here is it's a square root sign, okay? Now, remember what square root signs mean. Let me see, what do I do on this? There's a rule for surds, okay? Here's the rule for surds I'm going to teach you. If I have the square root of 100 over 25, everybody knows 100 divided by 25 is 4, yeah? You can divide first and do the square root second. So this in turn will be the square root of 4, which is 2. Okay, now what happens if we do it the opposite way around? We want the square root first and divide second. Does it affect it or does it not? What's root 100? Root 25? 10 divided by 5? Did it affect the answer? No, it didn't affect the answer. So we're allowed to do either one of them first. I'm going to apply this logic to this question here. Okay? What number multiplies itself? What number do you need to multiply by itself to make 9a squared? 3a. Because 3 by 3 is 9, a by a is a squared. So I just turned that into 3a. And on the bottom? 10b. It's still division, isn't it? Would you agree it's still division?
Yeah.
How do I change that to multiplication? 10b all over 3a. I'm going to change, that's 3a squared and 5b squared. I'm going to change that into 3aa and the other one into 5bb. What can I cancel? 3. 3. B with B. 10 divided by 5? 2. 2 over, 2a over b. Just pause for a second. They're still in a. Yeah? And 10 divided by 5. The 10 and the 5 interacted to become the 2. Is that right?
So if that's the 5 divided into 10, stays at the top. So the 2 goes to the top of the product. Yeah,
because 10 divided by 5 is 2. So it basically, it's like this. If isolated, it's like that. Yeah. Good. These guys. I think you're alright with the first two. Factorise and chop off the bracket, that's the same, yeah? I think what would cause you a hassle would be 33 and maybe, I'd say just 33 part 3, I'd say would be the one that causes you a lot of hassle. Okay. Have you ever done anything like this on its own? Just the top part. Oh, you did last year, I suppose. What do you need to do with that? And then what's left over? Okay. Would everybody agree that that part there is actually quite easy?
Yeah.
What does it turn into? X was 3 and? Okay, that's very easy. And then underneath, I am dealing with this here. How do you factorise that? X squared plus 2x minus 3?
Minus 1 plus 2.
I would say plus 3 minus 1. Yeah, you just obviously have to take your time doing it, yeah? And trust that you'll get the right answer. We got 15 minutes left. So plus 3 and minus 1. Anything that's going to disappear on me? Stuck there, that's my answer. My answer is x into x plus 4 all over x minus 1. Now where they'll get you is, some of you will try to strike off stuff. You can't strike off the x and you can't strike off these two x's. Can you tell me why? Huh? First of all, the x on the bottom is not a multiplication x. It's just a regular x getting stuff taken away from it. It can't be crossed off. The only one that could be crossed off is technically the only one that could be crossed off would be that one there, but it needs another multiplication by x on the bottom to make that happen, and it's not there, so can't happen. Everybody right with that? Brilliant. Now, anybody remember these ones? Explain to me what these are. It's just one fraction take away another fraction. Do you know how to do them at junior cert? Junior cert level? 2/3 minus 5/7. What should I do? Yeah, you're right. You'd get 21, and you'd do the. I'm going to show you a different way. I'm just going to write 3 lines. That one by that one, that one by that one, and then. So I'm linking the 7 to the 2, and I'm going to get 14. I'm linking the 3 to the 5, I'm going to get 15. And then the blue line on the bottom is 3 multiplied by, which is, and it's going to be minus 1 over 21. Same thing as a common denominator method. So what I'm suggesting with you guys is when you do these questions, you, as an example, part 6, 1 over 2x minus 3 minus 1 over 2x plus 3. Okay, what do you need to do first here? What are the 3 lines I spoke about?
2x plus 3
2 and 3. So what's the red one? The red one? And that is in the top left position. The next one? Now this one's a bit awkward because it's actually minus 1 multiplied by 2x minus 3. So it's hard to do in one go.
minus 2x plus 3.
It's going to be minus 2x plus 3. Is that what everybody said? Oh, fair enough. So multiply that out and you get minus 2x plus 3. Okay, so that's a 3 there, and now it's minus 2x plus 3. And on the bottom, guys. On the bottom. The purple line.
4x squared.
You don't necessarily have to multiply it out.
Just 4x squared, isn't it?
It's like that, but if you multiply it out, you get 4x squared minus 9. It's a difference of 2 squares, so the middle will cancel. The middle's going to disappear. So your answer is the 2 x's are going to cancel. 3 plus 3. So you could have one answer is like this. This answer is usually acceptable. Can anybody give me another answer that's acceptable? Huh?
Cancel the 2x plus 3.
No, because they're on the same level.
4x squared.
You're talking here.
The 2x plus 3 minus 2x plus 3.
That and there. Those two there.
No, like
Here.
Yeah.
This 2x plus 3 is not multiplied by everything on the top.
Yeah.
It's just a regular 2x plus 3. So to do what you're talking about, Luke, this would all need to be in brackets. On the outside of that, there need to be a 2x minus 3.
Yeah.
That's been multiplied by everything in the bracket for that to cross off that way. So no, you can't do that. It's best not to cross off anything to the bare end, unless you're really, really stuck. Just check the answer at the back of the book first. Give me another answer that's acceptable.
4x squared minus 9.
But you can always multiply out the denominator and get 4x squared minus 9. Everybody right with that? Okay. Did 4. And the only...
Good morning. Here today's announcements with Liam Brown.
You're asking these ones, show that. So I'm asked to show that the left side is the same as the right side. Some people get very confused about this little part at the end. Now believe it or not, this part actually does nothing. All what it states is that R is not allowed to be, R is not allowed to be a half, or R is not allowed to be minus a half. It's not allowed to be those two values. Is this a solved question?
No.
So you're not going to get an answer for R anyway, are you? So, not really going to influence you much. Now the reason why it says that is, imagine that you put R equal to a half, yeah? What's 2 times a half? So this, I'm working this part here. What's 2 times a half? 1. What's 1 minus 1? You're never allowed 0 on the denominator. That's why it's saying that. That's what it always does. It just says, if you have these numbers, it affects the denominator and the question won't exist. Is that alright? So in a nutshell, you don't really care about the green blob there. You're just working on the other part. Pick the left side, and it's like the last question we did, isn't it? Can anybody tell me what you're going to do?
3 lines.
The 3 lines, aren't you? So it's going to be 2R plus 1 when this one joins the one up there.
Minus 2R
Minus
plus
2R plus 1.
Yeah, you did it in one go, fair play to you. You did this in your head, and then you multiplied it out by minus 1, and you got minus 2R plus 1. And then it's all over 2R minus 1 and 2R.
Why did they go in the brackets at the bottom?
In the same way, a half minus 2/3, yeah?
Yeah.
3 goes up to the 1, 3. 2 goes up to 2 to make 4. And the bottom is actually 2 multiplied by 3. But we would have just turned it straight into 6, wouldn't we?
Yeah.
So I'm just simply not multiplying them out.
Okay.
Is that right? Same thing? Now, and what happens to the 2 R's? And we get 1 plus 1, which is 2 over 2R minus 1, 2R plus 1. And you're good to go, right? Alright. These ones. Now, it's the same thing, isn't it? A fraction take away another fraction, yeah? Now, here's a trick for you, alright? 5 over 12 take away 7 over 8. Are the denominators fully factorized? No. So my suggestion on a question like this would be 5, we change that into 4 multiplied by 3, we change the 8 into 4 multiplied by 2. Would you agree with that? Now, what's the difference? Would you still agree it's the same question?
Yeah.
Now, remember, denominators are jealous little buggers. They get jealous of each other all the time. What does that one have that I don't have? Okay? So this one looks over and goes, what does that one have that I don't have? It wants a 2. Well, if you put a 2 on the top, you must put a 2 on the bottom. Would you agree with that? And then on the other side? 3 on the top and a 3 on the top, 3 on the bottom. And then you're going to get 10 minus 21. What's that? 4 by 3 by 2, which is 24. And you're going to get minus 11 over 24, yeah? Now, we're going to apply that same logic that we just did here. We're going to apply that to these fractions here. So, it's going to look and go, first of all, are both my fractions fully factorized? No, that one's not, is it? So I'm going to rub that out and I'm going to factorize it. X plus 3, x plus 3, x minus 2. Somebody tell me my next step. The denominator on the left is going, what does the denominator on the right hand side is saying, what does the denominator on the left have that I don't have? So what does it have?
X minus 2.
X minus 2. Top and bottom, yeah? Now, like with fractions, do you see the way the two of these were the same fraction? Yeah? It's 4 by 3 by 2, 4 by 3 by 2, yeah? They joined into one fraction, yeah? Two denominators that are the same. can join into one denominator that's the same. That's what I'm going to do here. No matter what's going on with the top, the bottom is going to read x plus 3, x minus 2. On top we have 5x minus 6, and on the top we have minus 3x plus 6. What happens to the 6's? 6's cancel, and after that 5x minus 3x, 2x, and I'm done. Okay.